Good morning, everybody. Welcome back to the last lecture of this course, lecture number 36. Today we will have a very short lecture, not short, but in terms of the material. This is not required in the final, okay? It's not required in the final, it's just for your knowledge. I'm going to walk over it real quick. Then we'll talk about other topic until the end of the class, okay? So the last chapter, which is not required, 8, you are supposed to know about 8.7, 8.8, 8.9. Shahrani? So real quick, it talks about the computer architecture. But it's not really important. What matters is 8.7. This is for your own knowledge, interview questions, okay? Not exam questions. يعني هذه أسئلة, I think it's very important, especially if you plan to take the control course. So not required in the final exam, okay? Okay. So this chapter talks about computers, microcontrollers, computer-based information systems, but we only cover measurement and concept sensors, signal conditioning, and analog to digital converter. I will give you the summary, okay? So the first thing I want you to know about ya shabab is what are the stages of when you measure the signal, you use what? Sensors. So this is your hardware, okay? This is your hardware. The first layer is sensors that connects you to the hardware. So the sensors gives you a signal that looks like that. Not perfect. There is another block called signal conditioner that has processing capabilities to make the signal from this shape to that shape, so that we can process it further, okay? So what's the difference between sensors and signal conditioners? Sensors are directly connected to the physical phenomena, but the signal conditioners, they transform the changes in electrical parameters to voltages if the sensor output is not already a voltage. It could be a current. Some of the sensors, they give you current, they don't give you voltage. So signal conditioners, they put them under the conditions that you can process them using DAX, data acquisition, okay? Because the output signal from the sensor is usually weak, full of noise, the signal conditioner amplifies and filters these voltages. It makes sure it's a voltage, which it doesn't have noise. Why? To put it in the next block. What is the next block? DAC. You will see this in industry. What is DAC? Data acquisition systems. D from data, acquisition is AQ. Okay? One of the examples of DAX system is LabVIEW. Are you familiar with LabVIEW? Familiar with LabVIEW? Simulink? Are you familiar with Simulink? Michelle? So, sensors, signal conditioners, data acquisition systems. The conditioned signals are input to DAC board. هي تكون زي الأردوينو, data acquisition board. Inside the data acquisition, it has multiple components. The first component is sample and hold. خذ عينة ومسكها. Take a sample and hold. Take a sample and hold. Take a sample and hold. Then it goes to the multiplexer. the multiplexer, it picks those samples for further processing. What is the mux? What is the multiplexer? It's a device that picks up the signal that is wanted. The last component is in the DAC is analog to digital converter. Already told you about it. It converts analog data to digital, 1010. And then it goes to the general purpose computer or laptop or server, etc. So what did we learn today in this chapter? We learned that sensors are just the beginning of the story. The problem with sensors, they give you current, they don't give you voltage, they give you noisy signal. We go to signal conditioner. This is very important, ya shabab, if you work with Sabiq or Aramco. So what is signal conditioner? Is a device that removes the noise and gives you proper voltage. Then it goes to the DAC. What is DAC? Data acquisition board. What it does? Sample and hold. Take a sample and hold it. Take a sample and hold it. Mux is multiplexer, means to choose the signal. The last component is analog to digital converter. We always note that the sensor voltage in the sensors, it's proportional to a constant K times M, where M is the measured quantity. Okay? You calibrate sensors by changing the value of K. So if you go with Aramco, all of you inshallah, and you talk to the technicians and they tell you we need to calibrate the sensors, what they're doing is they're changing the value of K. How does that look from electrical point of view? Is they change the VDR ratio. VDR is very important, okay? What's VDR? Voltage divider rule. Rahim, we will have a VDR in the final exam with op amps, okay? Okay? We will have VDR with op amps. I'm warning you. واضح مشان؟ واضح بدنا؟ We will have VDR with op amps. Of course, you want to have your input impedance much larger than the sensor. You want to have to calibrate it properly, you want to have this ratio larger than the impedance of the sensor. Maybe 9 to 10, 9K, 1K, 15K, 2K. You don't want it to have 1K and 1K. Then you will get 50% of the voltage. Then you will have what? A weak signal. So the R for the amplifier, after the sensor, you want to have large input impedance. Again, there is a concept of sensors with electrical current component. Basically, instead of a voltage, you get current. They only have diode in place. So I want you to know that sensors with electrical current output, okay, you need to connect them with diodes, etc., to fix the problem, to get the voltage, okay? So diodes are used inside sensors in that. So we will require current to voltage converter. How we do it? It's not required by having this circuit. We have excitation, we have a diode, and then we have the current to voltage converter, and this system should give you a voltage. What's the output? Voltage. Other sensors produce changing resistance in response to change in the measured. For example, the resistance of a the thermostat, okay, changes with the temperature. Okay, the thermistor. Signal conditioning. So are we done with 8.7? I want you to know, the only information I want you to know is this block, okay? This block is very important. What is DAC? Data Acquisition System. If you want to improve your skills, you don't want to get master's degree, go and learn how to do DAC. Okay? For the signal conditioning, the purpose is to amplify the signal, convert current to voltage, supply necessary electricity, and filter out the noise. I already explained that. How to do it is usually we connect it with op amps. So if you connect op amp with the ground, for example, sensor, and then you connect the inverting to the ground, then you will have Vn. This is not a closed loop signal, okay? Or you can take the differential input. Both approaches are acceptable. If you have problems with noise, it can be either electric or magnetic. With electric, we use shielded cables. With magnetic, we use twisted pair cables. No, to get the bonus, you have to stay. Can't get the bonus on me. Okay, قلت يا شباب؟ So المagnetic ايش الكيبل المستخدم؟ شيلد. الالكتريك شيلد. المagnetic twisted.
عشان نوخر النويز.
To remove the noise, okay? So for the electric we need shield. For the magnetic, twisted. Okay, this is the only information that I want you to know. So let's repeat that. What do we need? The most important information is I want you to know this figure before you go for any interview with Sabiq or Aram. The second important information, this is not important, not really important, but this is important. To remove the noise, the electric field coupling noise, if it's electric, we use shield, اللي هي grounded shield. You connect the cable to ground. To remove the magnetic, twisted cable. The last component is analog to digital converter, which is this one, ADC. What is ADC, ya Ramadan? Analog to digital converter. Analog to digital converter. Know these abbreviations, please. These are interview questions. You will not get a job. You will get the job if you tell them what is DAC, what is ADC. You're mechanical engineers. You have to deal with sensors. What's the point of a mechanical engineer who doesn't know how to deal with sensors? He will become almost like a civil engineer. Same for aero. With analog to digital converter, the only information I want you to know is you need to have enough sampling frequency. You have to take enough samples. Twice as fast as the largest periodic signal. يعني, if you have, for example, electric motor that spins at 60 Hertz, you need to take samples higher than 120 samples, twice the frequency. اللي يسمونها Nyquist theorem. You will study Nyquist theorem in the control course. من اللي بياخذ السمر. Who will be taking the control course in the summer? You will see this. Okay? If the frequency of the signal you're studying is 10 Hertz, what's the minimum sampling frequency? Twice. 20. Double. Also, quantization, noise. You need to define proper digital amplitudes. You can't have 0 and 1. So in this case, for example, you need to have something for 8, 5, 4, 3, maybe 8.5, 5.5. So depending on how much the range, you need to define how many quantizations you have in your analog to digital converter. With that, we conclude this class. Now, what I want to talk with you today is pretty much research I do, or I'm planning to start. That's the proper way. It's 2 slides, okay? Some of the things I did, okay? Some of the things I did, just to see another part of electrical engineering that you haven't seen. What is this? So I am research in renewable energy grid modernization. ايش معنى grid modernization يا شباب؟ تحديث الشبكة. So every year Saudi electricity company etc. they improve the grid. And now we have renewable energy. Who controls the renewable energy in the kingdom? وزارة الطاقة. They have a مكتب الطاقة المتجددة. So they say who has the right to build wind farms, PVs, etc. I am affiliated with a Sustainable Energy Center or Laboratory, Sustainable Energy. Dr. Atif Zahrani, you know Dr. Atif Zahrani?
Yes.
He is our director. I plan to do research with them. My current research interest, I want to improve traditional system protection, power system protection, to adapt with the new technologies. What are IBRs? IBRs are inverter-based resources, anything that comes with the renewable energy. FACTS is flexible AC transmission systems, meaning that our AC system is becoming more flexible. I plan to develop a new algorithm to detect cyber attacks in the grid. إذا في حصل في الشبكة اختراق cyber security sort of things. And I want to still work on optimization of concentrated solar power plant. هي الطاقة الشمسية المركزة. One of the projects that I worked on before was this system. So let me ask you a question. What is G? Generator. Okay? G is generator. What is this tower? No, not transformer. Electric transmission tower. What is this? Transformer. You remember the transformer? What is the purpose of the transformer? Change the voltage. Interview question. What is this tower? هذا اللي نشوفها في الخطوط لما تمر على قرية صغيرة. If you live in a small town, electric.
High voltage.
No, this is medium voltage. High voltage اللي كذا اللي تجي كبيرة. Small voltage or medium voltage is this. In big cities here, Riyadh, Dammam, Jeddah, they put it under the ground cables, okay? This is also another transformer. What is this device, ya shabab? Capacitor. What's the purpose of the capacitor? To improve power factor. Improve power factor. So in this system that I studied before, the purpose was to study what will happen if I add solar cells to the stability of the system. If you add solar cells, the problem with them is all of a sudden they are disconnected, jet sahaba alayhum. They will generate high voltage in the grid. And these phenomena are studied. So you can see if there is a high, you see these are spikes, it's because we suddenly disconnected the PVs. Okay? I did also industry projects. One of the projects I worked with is if we add capacitors to the transmission lines, what will happen in terms of the protection. Protection means what to stop, what to not stop. I also worked in designing electric motors using particle swarm optimization, which is you want to build an electric machine. What are the parameters? So we talk about air gap, current density, electric current density inside the motor, the dimensions of the machine, the stator or the rotor. The rotor is the spinning part of the machine, and then the final design, and then finite element analysis. So I'm still interested. If you want to work on electric motors, talk to me, okay? Probably this is the most useful project for ME students. Maybe aerospace, not really. And I told you before, since day one, what is the area where electrical engineers and mechanical engineers have to work together? Electric machines. Electric machines. Machines from mechanical. Electric from electrical. There might be a course in the second semester that teaches you electric motors. You should try to take it. If you're interested, maybe I will teach it. Who knows? 252. Electric machines. EE, it's EE, level 4. Elective. I don't know, 4 something. It's called electric. I can find it now. I could be teaching it, someone else might teach it. Not 306. 306. You can also take the one lab, the 306 lab. I forgot what it is. No, not this one. The electronic. In 462, well, the problem is the prerequisite. 380 is the control course that you will take. 360 is the electric power course. So maybe if you're a senior, maybe you can talk to the chairman, they will remove the requirement for you. Dynamics of electric motors, steady state, DC motors, speed control, braking of the DC motors, dynamic analysis of induction machines, starting speed control, braking, steady state of dynamics of synchronous machines, special machines, control and application. It might be offered 252. It teaches you how to do electric motors. Okay. It hasn't been offered in the past 2 years. Okay. So, yeah. So what are the findings that I aim to? Is there is a need to innovate in developing new methods to detect cybersecurity in electric grid. Existing protection systems need to be enhanced to adapt with the renewable energy. And also there is still hope to have some of these big plants. These big plants have giant mirrors. They need motors to control them عشان تركز الطاقة الشمسية على البرج.
Why not the regular plants?
خلايا شمسية, that's different. خلايا الشمسية, they have their own thing. This one concentrated heat. زي concentrated مرايات هذه مو خلايا شمسية.
ليش هذه مو بذيك؟
This is technology, زي الwind had another technology. This one, in this tower you have big generator. So instead of burning fuel, you get the heat from the sun. These are currently under research in Spain, United States, and المغرب عندهم واحد.
دكتور is the heat enough?
Yes, more than enough. 1000 درجة مئوية. يحطون ملح مع المويه. Then there is a generator, typical generator. But these one, the problem with them, they are very expensive. Infrastructure, space, وتبني برج. So you really need to optimize their costs. They are very expensive. That's why you don't see them. Okay? And every mirror needs motors to control them. You can't have a DC motors حق الألعاب اللي نشوفها في no. You need big machines, big motors. Also electric vehicles, يا شباب, if you're interested, let me know. Why am I telling you this? I am trying to build my research teams. I don't have enough students now, just joined a few months ago. If you see yourself want to do research, want to try to do some simulation, talk to me. Maybe there is a space for you, okay? سامحوني يا شباب إذا في أي تقصير. I wish you all the best in the final. Until the next time we meet. بالتوفيق في حياتكم الدراسية والمهنية. Okay? يلا بالتوفيق.